Hello everyone, introducing, my name is Aquino Purba, the presenter of prototyping adaptive cruise control on electric motorcycle paper in ICIMECE 2020 with corresponding author Professor Muhammad Nizam and other authors Maghfiroh, Mufti Reza, Aulia Putra, and Inayati. And then we go on, start from the first, which is introduction. The number of motorcycles in Indonesia is always increasing every year. So the technology vehicles distributed in Indonesia is still limited to internal combustion engines, and the impact is increasing the use of fossil fuels and air pollution. So the solutions: public demands, environmentally friendly and fuel-efficient transportation. Electric motorcycles are vehicles powered by electric motors and used electrical energy stored in batteries can operate using electrical energy. Features of electric motorcycles in Indonesia are disc brakes, near and far lighting lights, turn signal, brake lights, and horns. An additional feature need: drivers unfocused while maintaining constant speed cause traffic accidents. Additional features needed can warn and stop the electric motorcycle before crashing into other vehicles in front of it. Cruise control is an automatic technology to maintain constant speed, currently developed into adaptive cruise control, which can detect the speed and distance of the surrounding vehicles. Adaptive cruise control, abbreviated to ACC, adapts to the traffic situations, increase driving safety, handling emergency brake situation, and fuel use efficiency. From the previous research, mainly in software simulation and hardware, but only for cruise control for electric motorcycle or for motorcycle. So objective of this research is making prototype, simulation, and also hardware of ACC for electric motorcycle based ultrasonic sensor. For the method starts from designing a series of adaptive cruise control with Proteus 7.9, and we make prototype consists of two stages, which are electric designs and software designs, which the code in Arduino code, and we test the prototype itself with data were taken about system response to variation in distance reading and their effects with changes in current, voltage to the electric motor, and changes in PWM values. And the data validation is done by comparing the results of PWM duty cycle changes between simulations and prototypes with the same distance variation treatment. And then result and discussion. Here the results of circuit in Proteus 7.9, and the picture below is the prototype itself with explanation each number of each part. So we can see from the first until 9 clearly in this table, and the next table is the variation results of prototype test. So we can see in the distance in such a distance the changes of voltage, duty cycles, motor speeds, and LED condition. And data validation result. The data validation result shows that in a graphical representations in picture beside the table, we can see the x-axis is the value of distance variation in centimeter, and the y-axis is the duty cycles value in percents, PWM. Orange is prototype graph, and the blue is a simulation graph. Obviously, the error occurred the change in data between the simulations and the prototype formed a graph that almost coincided because the error value occurred below 0.45%, except in the range of 25 centimeters until 49 centimeters, where the biggest error lies at a distance 40 centimeters and 35 centimeters. In the simulation, the change graph for the range 25 centimeters until 49 centimeters has a linear increase, while the prototype has an increase with a non-linear graphical form. Error occurs because of interference of external factors such as vibrations and coupling when testing prototype. And for the conclusion, from all of the elaboration of the correlation graphs, the distance of the placement of the object's barrier to change in the motor voltage, PWM duty cycles, and motor speed indicates the adaptive cruise control mode can run well. The data validations found the average testing error obtained was plus minus 1.53%, meaning overall the value of PWM changes to the variation of the ultrasonic readings of the prototype run well and with errors that occur below 5%, so that the tests carried out are valid and the system may be applicable to electrical motorcycles as an additional feature by adjusting in real condition. Thank you very much. If you have further question, you can ask our corresponding author, which is Mr. Muhammad Nizam.